Hi, how's it going? I'm Doris the chef, and this is a demo for my first AI agent, DataCraft, and how it was built. This AI agent is designed to generate synthetic datasets for female breast cancer patients. Specifically, it can simulate data for 100 patients, each characterized by 30 distinct features. Let me begin by opening the GitHub repository for this project. So this is an example of what it produces. As you can see, the AI generates realistic records for 100 female breast cancer patients. Each patient profile includes 30 diverse set of variables covering areas such as demographics, disease status, prior therapy, and lab measurements. To build this AI agent, I think there was three steps which I will walk through. So the first step was figuring out what kind of data I want this AI agent to generate. After some thought, I realized it would make the most sense to focus on patient data for a specific disease. I choose female breast cancer partly because I'm personally interested in it and also because it's become a more serious topic in recent years, especially with more young patients being affected. With that in mind, I decided to build this AI agent to generate data sets for female breast cancer patients. So I talked with my mentor, Dr. Yang at CABS, and we finalized the 30 key variables with their distributions, parameters, and realistic minimum and maximum values. You can find a full variable dictionary over here in this README file. Now that some variables have conditional relationships, which I need to make sure these relationships are included in the data. For example, menopause status should depend on patient's age, and HER2 status should align with whether or not HER2 therapy was given before. And this wraps up the first step in building this AI agent. The second step was to clarify the structure of this AI agent, figuring out what files and components are needed to make it all work. To keep things simple, I built a simple version of DataCraft. This repository, we can take a look over here. This project has an API implementation, so makes it a real AI agent, and it can generate 100 patients, but each with only four variables: age, disease, gender, and name. So the key component of this project is this generate patients.python file. It has API implementation, which turns this project into an AI agent. It connects to Google Gemini AI through a Flask backend. The front end is just a simple HTML web page, giving users an intuitive interface to interact with the system. Now let's open this simple version of DataCraft in Cursor and take a look at it. I will first activate the virtual environment, and then I will run this project. So a web interface will pop up, so we can generate 100 patients. Here we'll put 100 in here, and we'll click on generate. So right now, 100 patients with four variables, name, age, disease, and gender are being generated by this project. It takes like less than 1 minute to generate 100 patients. Their names are realistic. And after it's generated, we can also click this button to download a CSV file to use it. Right now, we can see that this data is in a JSON format, but it's fine since this is not our final product. So this is the second step in building this AI agent. The last step is to implement 30 variables with their specific distributions or percentages. The main improvement in the last step is, let's take a look, is that we built a tool for the AI to use in this generate patients.python file. In this tool, there are two functions that the AI can use. One generates values following a normal distribution using parameters for mean, standard deviation, minimum, and maximum. The other generates values based on a log normal distribution with the same parameters. In the AI prompt, um, I include examples of how to call these functions and their expected outputs so the AI knows exactly how to use the tool during the data generation. Now let's run this final product again. Again, we will activate the virtual environment first. And then we will run this project. Also, web page has popped up. We can choose the number of patients we want to generate. Here we'll only generate 5 patients. As I've timed before, it takes about 3 minutes to generate 100 patients. To save time, we would only generate 5 patients over here. Yeah, so we have 5 patients with 30 variables, and we can download a CSV file and use it in our local file. So this AI-powered tool is ideal for medical education, software testing, research simulations, and database prototyping. By automating data creation, it saves hours of manual work while producing realistic and diverse patient profiles. Thank you.